So now we have been given a table here with some data to find probabilities. This is using our experimental or empirical probability for having data and using that to determine our probability of different events happening. So in this one, we have been given or told that a university cafeteria surveyed the students who ate breakfast there for their coffee preferences, and the results are given in this table, which is what we actually call a two-way table. And now how this works is if I look at the row freshmen, my intersection here of 23 is intersecting with the column of do not drink coffee. So that means 23 of the students that they surveyed selected yes, they are a freshman on their survey, and they also selected they do not drink coffee as their choices. We also have 145 freshmen that prefer regular coffee and 69 freshmen that prefer decaf coffee. And now if we add those three numbers together, that gives us the total for this row, meaning that there are 237 freshmen that answered the survey, regardless of what they chose about their coffee preferences. We can also go down the columns to take a look at this, that we have our 23 freshmen that said they do not drink coffee. We have the 18 sophomores that said they do not drink coffee. And now if we add those two together, we get the 41 students that said they do not drink coffee, ignoring whatever they said about freshman or sophomore. And then in the bottom right corner of this, we have our total number that were surveyed in total. And you can find this value, if you weren't given it, by adding your totals together in either the column or the row to get that final number of the total number of people surveyed. So now we want to find some probabilities with this. We have been asked first to find the probability that the student does not drink coffee. So this means we are going to look at the do not drink coffee column on this, and we need our total for this, which here is 41. So our probability that they do not drink coffee, well, we have 41, and then we need to divide this by our total number of elements in our sample space, which in an empirical table, that's our total in the bottom right corner, our total number of people surveyed. So this is being divided by 497. And now a lot of the times with the empirical probability, we don't usually keep them as fractions. We put them into their decimal place. You can choose to keep it as a fraction or simplify the fractions if they work nice. But here I'm going to evaluate what this would be. So 41 divided by 497. And I get that this is approximately 0.0825 if we round to 4 decimal places. The next one, we want the probability that the student is a sophomore. So now we see that sophomore is a row on this table. So we are going to find our total for that row, which we are given as being 260. So the probability that they are a sophomore is equal to 260 divided by the total number of people surveyed, which is still 497. So now 260 over 497, this is approximately 0.5231. The next one, we want the probability that the student is a freshman who prefers regular coffee. So this means we want the students that selected they were a freshman on their survey and they selected that they prefer regular coffee. So that's going to be the intersection of the column and row for those two things. So we see that our intersection of freshman and regular coffee has the number 145. So 145 students said yes to freshman and regular coffee, and this is still being divided by 497 total. And now that we can evaluate to be about 0.2918. And then lastly, we want to find our probability that the student is a sophomore and prefers decaffeinated coffee. So we want to find our intersection of those two column and rows. So our sophomores that prefer decaf coffee, we see that there is 46 at that intersection. So our probability of sophomore and decaf coffee, we have 46 out of our 497 total, which then that we can evaluate to be about 0.0926.